Okay, good day everyone. Here is another system before us, and then what's the problem of this one? It's dead, completely dead. You insert the power cable, the adapter, it doesn't show anything. It's a Lenovo laptop, and then it's just it's just not coming on. It's very dead. So we are going to be troubleshooting to know what the problem is. So where do we start from? We are going to check. Here is the power cord, the adapter that came with it. We are going to check if it has power at all. I'm going to check if it has power at all. Let me quickly confirm that. Get it connected. Let's see if it has some voltage. I think we need to see the screen of the voltage of the multimeter. Does it have voltage? It's got no voltage at all. The customer complained that it shows no power. Okay, the power is not switched on. Okay, it has some voltage. Yeah, that's 20.6 volts, which is okay. Let us check and confirm if what the owner is saying is correct about the fact that it doesn't show no amber lights, no indicator that it's charging. So that means the board has an issue. So we are going to lose the system. We're going to bring out the PCB, the motherboard, and then we'll come back for the repairs in details. Thank you. All right. Now the board is already opened, and then let us check what the challenge is. Let's check. Let's confirm from the charging port. The other time we tested the power adapter, the power adapter, and then we saw that there's power here. So there is still power. And then let us confirm if the charging port is okay, if it actually brings in power. So let's do some continuity tests to check the ground and the positive terminal, positive pin of the charging port. So let's do this now. With that sound that you are hearing, the sound we are hearing, it shows the ground is okay on the charging port. And let us check the ground too, the the positive pin. Now the positive pin has no response. It's expected to give a resistance as in diode resistance since it's in diode mode, but it's not giving anything. Well, now let us trace that positive pin. There is the positive pin here. I think there will be need for us to focus on this, the charging ports. Now this is the positive pin on the charging ports. Now from this positive pin, it is coming from here. Let us trace it. Where does it land? Where is the first MOSFET? There are two MOSFETs. Most times there are two MOSFETs after the input pin, the positive input pin. The first MOSFETs, let us locate it. There are two MOSFETs around here. In any board, you have two MOSFETs always. And then I think the first landing point is this. For this pin, it's landing here on this MOSFET, and then it will come out on the other side. Then from this side of it, it lands on this second MOSFET. Then from this place, it comes to this other side. So from here, it's coming to a current limiting resistor. So there is a current limiting resistor here. It is from this current limiting resistor, and we can see it's always a very low ohm. You always have a very low ohm, like a fuse. So and then it is from these current limiting resistors that the voltage coming from the input pin of the charging port, it is from there that it goes to every part of the board, to all the positive, to all the, everywhere that there will be need for us to have the 18 volts, 19 volts, 20 volts, depending on what the system is designed for. So now, from what we can see from this point, all of this recurrent limiting resistor is shorted to ground. Shorted to ground, meaning that the positive, the power rail, that is the main power rail for this board, is already shorted to ground. And when that happens, the system can never come on. So it is either a capacitor, a diode, or a MOSFET is shorted. So we need to find out, and that's where we're going to be introducing a voltage injection. We are going to be injecting voltage into the board, and we'll try and see if we can locate that on this board. So let's get that started. All right. So if I think it will be good I remove the board. Let me remove the board. When the board is taken out of this, we'll come back for the video. Come back. And also a very low current. So let us start with say like 1.2 volts. 1.2. Can you see the screen? 1.2. Then give it a very good current and see. Let us see if that can resolve anything, or that can showcase the problem. So this is the MOSFET. This is the what's it called? The current resistor that goes to the board, to every part of the board. So let us check the problem there, if we see anything. Let's check. Is anything getting hot? The voltage has gone to 0 actually. So because of this kind of multimeter, because of the kind of power supply that I'm using, it doesn't have that capacity to push too much current. Because I remember in one of my videos, somebody was telling me that the voltage I injected was too much. He was calling me names, but that's the essence of the video anyway. You get to meet a lot of persons. They want to actually educate you, but they are the manners with which they know how to do it is not the best. So he was trying to let me know that the voltage was too much. I knew actually I am aware that the voltage, but for this kind of the voltage regulatory device that I have, this power supply, if you put in a particular voltage, the current is not that much that it can damage anything. I've used this over and over again. I've used it to discover problems. You get? So I've used it to discover problems, and then I've been able to resolve them. So we are going to do this. I'm giving it a 5 volts this time around. 5 volts, because if I giving it a 5 volts and reduce the current, something has to get hot. Something is expected to tell us that I am here. I'm the one consuming all the power that you just sent into this board. Because we can't have 5 volts and it goes to 0 just like that. It's going through that particular component to ground. And that's I can feel some warm around here. if I'm not wrong. Let me increase the voltage to like 10 volts. I understand my power supply, and I know that that's the, I need to increase it gradually such that I can get out, I can, I can fetch out the, fetch out the part, the culprit, that component that is shorted. We'll get it. Still can't find anything. Still trying to find it. Okay, let me give it some better current. Zero 0.3. A thermal camera will have been the best to find out this problem, but by God's grace, very soon that one we'll get to see them. We'll need to get one. We need to get one. So it helps to find any heated spots very fast rather than doing this manual filling. So it will be the thermal camera that will just mhm. 1.1 volts. Where is it going? I can feel some heat around here now. So like I said, I understand my own power supply. So the heat is around here, and I'm not sure there's any component at the back, but there is. Let me check if the heat is at the back directly. Wow, it's at the back. I'm feeling it at the back here. So I'm suspecting that is a capacitor, but let's know which capacitor is that. I need to be sure. This time around, is around. The problem is around here. The capacitor is at the back of this. Now let's use some fuel to do a test to be sure which of the capacitors You sure which capacitor has that problem? Okay, can't locate it. The best thing that I should have done is to find a cable, find a wire, solder it here and extend. But my soldering iron is not plugged at the moment. It's not plugged. It's not plugged. So let me see if I can plug it and connect a wire out there. So it makes the troubleshooting very fast. I'll connect it and expect it to get heated up. That I said that needs to be connected so that I'll be free to do some filling, hand filling at the back of the board has been soldered to that point where I'm injecting the voltage. So now I'm going to tie this around so it's around 14.2 at the moment with a lesser current, and I'll be putting I'll be tying it around this to know where the voltage is being consumed at the back of the board. So I'm feeling it at the back of these chips here, at the back of these chips, these transistors. So let's get exactly where it is. It is at the back here. So how do we now know? So let's just put some fuel at the back, like we all know, and see which one is heated up, is getting dried up on time. Anyone that get dried up on time is the one that is consuming the power, and that is bad. So I can see this capacitor is short to ground. It's obvious that the capacitor is short to ground. So what do? We just quickly engage our workstation, engage the workstation, and remove that capacitor very fast so that you can quickly resolve this. You can see fixing problems on board does not really take time if you know what you are doing. It doesn't really take time. It takes understanding and the required knowledge to do what you need to do and get out of the board and move to another thing. Can't spend the whole day fixing a board if you know what you are doing. So I want to remove this capacitor now. Capacitor is short to ground as we can feel it. I just like to put it at one side. I'm not removing it completely. I just shifted it aside so that I can easily do a test on it. It won't be flying up and down. Now let me take this to resistance, a diode mode, and check the capacitor if it's actually shorted. Now you can see capacitor is shorted without sound. You can see short to ground. Now let us go back now and test that point where we said it's shorted to ground at the injection point where we were injecting the power. That there's no more short there. The short is gone. It's no more giving any beeping sound. So it's giving the right resistance value, which is supposed to give. It's giving like 352 volt, 352 ohms, which is okay. Which shows that the problem is resolved. So having done this, I believe the issue has been resolved. I will just need to remove the cable, the ejection cable, and then get the system coupled back. We'll return when the system is coupled back and then power on the system. So the system has been coupled back, and then now we'll need to put in the adapter or the charger for the battery, so and check the status of the board now. All right, can we see amber light? Can we see it? Can we focus on the so that shows that this was not happening before we resolved that issue, but now we have been able to resolve the issue and the amber light is common. And now we will check the voltages on board if they are all the voltages are present. Now at that point where I was injecting that voltage, now I have 20 volts there. Can you see the screen on the multimeter screen? Now I have 3.4 volts, which is needed to power on a system. We have 5 volts, which is also needed for a system to be on. Then we have 1.8. This we have also okay here, because we have not powered on the systems. Some voltages will not be available. Now if you check the super IO, we have 3.3 on it, and then other necessary voltages are there. So this is the coil for the charge for the battery, the coil that charges the battery. So the battery is being charged. You can see as the voltage is increasing from 8.5 to 8.6. So everything is okay now. So that gives us a kind of assurance that the system must power on all the voltages needed on a board is available. So let us try and see if we can power on the system now. I think the casing is broken. So the system is powered on already. It's powered on already, and the system is on. So that's the power of voltage injection. You can easily pick out the faulty components, get it dealt with and rescue the board. So this is Nitty-Gritty electronic repairs. If our video has been impactful to you, we'd like you to subscribe to our channel, give us a like, your comments, we need your comments, and we'll respond to you. If you have any question that you need to ask concerning what we have done that you don't understand, you can feel free to ask your questions in the comment section. Also kindly share the link of this video and let it go viral. So see you in the next video. Thank you.